Welcome to Rawson Connection, a podcast about all things Lehigh engineering, coming to you from the P.C. Rawson College of Engineering and Applied Science at Lehigh University. It's a show for students, alumni, faculty, and staff, current, former, and future, and for anyone interested in the many creative ways that engineers are solving the world's problems. I'm your host and producer, Christine Fennessy. Terry Hart was supposed to give the commencement address in May for the class of 2020. And it would have been a particularly interesting speech, given who Terry is. He's an alum of the Mechanical Engineering and Mechanics Department, and currently a professor of practice in that department. But Terry is also a former telecommunications executive, a fighter pilot, and an astronaut. In April 1984, Terry spent 168 hours in orbit. It was a historic mission, and one that nearly didn't happen for reasons we'll get into later. Terry's past is full of remarkable stories, many of which he shares with his students to illustrate engineering concepts, and some of which pull double duty by offering life lessons of sorts. Terry was going to share a few of these experiences in his commencement address. But like so many things, graduation was upended by the pandemic. We wanted to learn more about the path Terry took after his own graduation from Lehigh, and about the stories that shaped him as an engineer, pilot, astronaut, professor, and as a person. And as you can imagine, it's a lot. So this is the first of 2 episodes in which we'll follow Terry's path from a kid inspired by Sputnik to a professor in awe of his students. In today's episode, we'll learn what initially captivated him about space, the edge engineering gave him as a pilot, the most important failure in his life, and why Sally Ride was his favorite co-pilot. Thank you so much for taking the time to do this. I am really excited about it. So, okay, I want to start at the beginning. What kind of a kid were you growing up? Like, was there anything about what you liked to do as a kid that, looking back on it, maybe set you up for this very technical, very adventurous path that you eventually took?
My mother spotted it very early. I was probably not much more than a toddler. And unfortunately, I like to take things apart. Like one time she walked in the kitchen and here I had taken the oven door apart and was pulling all the insulation out of the oven door. But I was always fascinated by why things work and how they work and how to make them work better. All those kind of things that engineers like to do started very early with me.
And why the oven door?
I was in the kitchen and she wasn't watching me well enough. Fortunately, the oven was off. It wasn't a hazardous thing, but I had a screwdriver and I learned very early how to unscrew bolts. And every time I saw a bolt, I tried to unscrew it, So it took her about a day or so to get the oven door back together.
Oh my gosh. Okay, that's so great. All right, so fast forwarding a little bit, you tell this story about being 10 years old and seeing Sputnik in the sky. And, just to refresh listeners, the Soviet Union launched Sputnik in 1957, and it was the world's first artificial satellite. Was that the moment when you first thought about flying? Because astronaut really wasn't even in our lexicon until about a year later.
That's right. There was no career path to being an astronaut at that age. It was more an awe-inspiring moment because the reaction of the country was so dramatic at that time. So, I was growing up in Pittsburgh, and it was in October, and maybe a week or so after they launched Sputnik in the newspaper, there was an article that was going to be coming over Pittsburgh right after sunset. And you can see satellites quite well when the sun's still shining on them and it's dark on the ground. And Sputnik was tumbling. So as it came over Pittsburgh, it sort of was like a blinking light. And all of our neighbors, I recall, were horrified. They thought here that the Russians had taken control of outer space and that we were all going to be their minions. So it was a kind of an earth-shaking moment for the country in general. And for me, I reacted very much to it. And I was fascinated, of course, by the science and all that was behind it.
But what was it about seeing that moment of seeing Sputnik that captivated you so much? I mean, it was the size of a beach ball, this tiny thing in the sky. What made you think of science when you saw that?
Just the wonder of how it could go around the Earth every 90 minutes, to someone that's 10 years old or even to an adult. That's pretty remarkable.
Okay, so you got your undergraduate degree at Lehigh in mechanical engineering. And after Lehigh, you started working at Bell Telephone Laboratories, and the company sent you to MIT for your master's in mechanical engineering. What did you do at Bell exactly, and what made them such an engineering powerhouse at the time? Because you've said that NASA had a very high opinion of Bell.
Yeah, Bell Laboratories was unique in that it was wholly owned by the Bell system, AT&T, and T, and Western Electric, the manufacturing arm at the time. And that was a large monopoly. So they really could fund the research at a level that most private corporations could not afford to do. So about 80% of the research was directed toward designing and manufacturing equipment for the Bell system, the telephone system. But there was probably another 20% or so that was just basic pure science, where we're trying to understand space physics. A lot of Nobel prizes, were given to the Bell Labs people in that part of the business, and they just did so much for the whole country, to further science and technology. So I was so fortunate to be part of that. And NASA, as you suggested, NASA was very much involved with using Bell Labs for the Apollo program, and the Department of Defense using Bell Labs for research in nuclear weapon systems and so forth. So it was a wonderful place for a young engineer to start his career.
Wow. But you weren't there very long at Bell before you took a leave of absence in 1969 to join the U.S. Air Force, and this was during the Vietnam War. Were you drafted?
No, I wasn't drafted. In fact, Bell Laboratories could keep me deferred because we were working on the anti-ballistic missile system at the time, the Nike X, as it was called at that time. So I could have been deferred, but I wasn't happy with that kind of result. I wasn't very much in favor of the war, but I also didn't want to not do my part. So I enlisted in the Air Force and went to flight training. And frankly, I liked the idea of learning how to fly and mixing technology with operations. So I just finished my master's at MIT and was on my way back to Bell Labs then, and they said they could give me a leave of absence for 4 years. So I figured I'd go in the Air Force for the 4 years and then return to Bell Labs, which is what I did then.
Okay. And so to this point, you hadn't flown yet? You hadn't learned how to fly?
That's right. I never really had any flight lessons or anything like that, but the Air Force takes care of that. In fact, they actually would prefer that you didn't have private lessons as a pilot because they have to undo that teaching to teach you the military way of flying.
I see.
Yeah.
I see. Well, and so I think it's probably safe to say that a lot of people who join the Air Force do so hoping to be a pilot, but they never make it. It's actually very difficult to become a pilot, from my understanding. What do you think gave you that edge that ultimately turned you into a fighter pilot?
Well, the experience of going through flight training for a year is wonderful, especially for an engineer like I was at the time, because again, you're mixing all the things you learn about physics and mechanical engineering and propulsion and aerospace and all that. You're mixing that with the task of flying, not just flying the airplane, but also the mental tasks of planning a mission and being part of a formation, maybe leading a formation where you have to constantly be thinking ahead of what happens next. It's that marriage of technology and operations that I always loved.
How do you think being an engineer helped prepare you for those other operational tasks of leading a formation and that sort of thing?
It's interesting when you go through pilot training. Maybe only 10% of the officers in training have engineering backgrounds, and there's plenty of English majors and business majors. But if you do have an engineering background, it makes it that much easier to get a feel for what's going on. Why an airplane stalls. The whole understanding of the equipment is key to becoming a good pilot. A lot of people do fine, as English majors. They figure it out, And but I had lots of conversations in pilot training with my colleagues because they would pick my brain about the engineering a little bit, and I would help them understand what's going on in the academic classes that we had.
Wow. And so did you deploy to Vietnam or did you serve stateside?
I served stateside for I was the top of my class, so I got the first choice of the 50 airplanes that were coming down. So I picked a fighter, the F-106, that was an air defense fighter. After a year of training in that, then I was up in Maine doing the coast defense mission Russian bombers flying back and forth to Cuba. We'd escort them up and down the coast for a year or two. And then I got my orders for Vietnam in an F4, and I was on my way to training. It was actually going to be an F4 to Thailand. That was right. That was late 72, and the war was winding down. So before I ever got there, they canceled my orders, and I was fine with that. That gave me a chance then to leave active duty and join the reserves.
Okay. And what about, any instances from your time as a fighter pilot that later on would prove to be an asset to you in your work as an astronaut?
That was critical, actually, the fact that I had that flying background with the National Guard. So the whole concept of military flying is built on teamwork, but also, again, understanding how to manage machines, complex machines, in complicated environments where things are changing all the time. That whole field of operations is what NASA's all about. So the people that come from military backgrounds usually have a pretty good grounding in that.
Yeah, yeah. And are there any stories that sort of from your time in the Air Force that really sort of exemplify that teamwork or, being cool under pressure that might have really been something maybe you unconsciously tapped into later on in your career as an astronaut?
I tell some stories in my ME 255 Introduction to Aerospace course. I could relate to a couple of those, I guess. Critical, again, is understanding how the machine works and everything. I was on the wing of a fellow pilot that climbed up through some icing conditions, and he had forgotten to turn on the heater that keeps the icing out of the airspeed indicator. So his airspeed indicator broke, and it was nighttime. We were in between thunderstorms, and he took us into a stall. And all four of our engines quit. His two engines quit, my two engines quit. So I'm 10 feet away from him on his wing, and I can't see him. I went back to first principles. The battery kicked in and turned the emergency light on. I banked to get away from him. And then all my instruments were gone. So I just used one little turn gyro in the corner to indicate that my wings might be level and let my airspeed build up so I could get the engine started about 10 minutes later once I got lower. So that kind of understanding of how the hardware works. There's no emergency checklist that says when that happens, you do this, this, and this. So even if there were, I couldn't read it because we were in a difficult situation. But you know from your engineering training how things work and what's backup and what's not backup. And I knew the backup gauge was down there, and it was hard to read, but I could at least keep my wings level until we got down low enough. And that was one of about 6 or 7 stories I tell all the time to my students, because each story kind of relates some aspect of the importance of learning about the equipment you're using and the mission you're flying, so that you can respond in some unpredicted situation.
Yeah, I was going to say, what is sort of the underlying message that you try to pull out of that particular story for your students?
Well, that particular story I tell when we talk about how we measure airspeed on an airplane. It shows you what happens with the instrument when ice gets jammed inside it. It tells you you're going faster than you really are. So my leader ended up thinking he was going fast when he was really going slow. And we were going so slow that the engines quit, at that altitude. The air was too thin, So that's a case where it shows exactly what happens. And that happens every year or so, it seems, with some airplane. One of the most tragic was an Air France flight left from South America, maybe 8 or 10 years ago now. And it was up at high altitude, and that happened. And the co-pilot got confused, and he stalled the airplane in a flat spin. And it took them 2 years to find the airplane. And they finally figured out what happened. It was an icing condition and airspeed probes.
Wow. Okay, so 4 years later, after your active duty, you're back at Bell Labs. You join the New Jersey Air National Guard, and you get another master's degree in electrical engineering from Rutgers University. And then you receive a couple of patents for work that you did at Bell. What were those patents for?
Well, I was working in an electronic power design group. The entire telephone system, most people don't realize, but it actually floats off a very large battery. So if there's any kind of power interruption, the phones all still work. So it's all DC battery. So we would design the equipment that would keep those batteries charged from the grid. One was a safety device where when you plug the converter in, it would keep it from arcing so it wouldn't spark. And the other one was a noise suppression circuit that would keep the switching of the converters, the noise that would produce, electronic noise, would keep that from getting into the audio links, the voice channels on that digital conversion process. But Bell Labs was averaging four patents a day back then.
Wow.
Yeah, it was a remarkable place to work, and I wasn't the only one on those patents. I had other engineers and technicians that were got their names on those patents too.
Okay, so now in 1978, you see an ad in a National Guard magazine that NASA is looking for astronauts. And at this point, the moon landings are over and the focus for NASA is on building and flying the space shuttle. And so 8,000 people apply to be filling one of these 35 positions for astronauts, 6 of which are actually going to women. So for you, that means 29 positions, right?
Right.
And so I had read that you figured you had at least a decent shot of making the initial cutoff. And so why was that? Like, what was and is NASA looking for in its astronauts in terms of like education, experience, et cetera?
Yeah, actually, at that time, they were going to select the first group for the space shuttle, as you said there, and they hadn't selected any astronauts for 6 or 7 or 8 years, and there were still 25 of the Apollo astronauts still at NASA, some of which had not flown in space yet, and some of which had walked on the moon. So we had a kind of a mixed bag there, but they did change the paradigm a little bit in what they were looking for, and for the first time, they were now hiring mission specialists. So there were two different roles they were hiring: the pilot astronaut and the mission specialist. So that was kind of akin to the Apollo scientist astronaut at the time, but more general. And they were really stressing. You could tell in the interview process and so forth. They were really stressing what kind of teamwork you had done, your experience working with teams, trying to do difficult, complex tasks, because they were trying to prepare the astronaut corps not to be strong individuals. They had plenty of those kind of people during Apollo, but they saw the future as being much more collaborative between mission control and the crews and the scientists and so forth. And you could really see that come through in the kinds of people they were interviewing.
Yeah, that makes sense. And so while you're still in this selection period, was there any particularly memorable physical or mental training tests that you had to take during the selection period before you knew that you actually were an astronaut?
Yeah, they would take us. They tested 200 of us, and I did think there was a good chance I'd make that cut to the 200. And then the final selection of 35 came from those 200. So they take 20 of us each week over the summer of '77, and you go through a whole week of testing, much of which was physical testing. Here they had the doctors there at NASA had all these very willing guinea pigs to perform all kinds of stress tests on and see how they would perform. So that was part of it. And some psychological testing as well. So that was all very interesting. But the key event of the week was a 1-hour interview with the selection board, which was chaired by George Abbey, who ran the flight operations, and co-chaired by John Young, astronaut John Young, who was the head chief of the astronaut office. Of course, so that interview would be key to who they would select out of that 20 a week leading up to the final 35 that they had chosen.
And can you elaborate at all on those stressful tests that you had to do?
Yeah, they were interesting. Some of the psychological tests were more like a psychiatrist would ask you, how you felt about your mother and the way you were raised, or that kind of thing. Other mental tests were repeating numbers backwards and things of that nature. And oftentimes it occurred to me they were watching you and think more than how many numbers you could repeat backwards. They wanted to see how you reacted when you couldn't do it anymore. When you failed, basically they wanted to see, whether you got angry or or pounded your back. I think, there was a lot of that kind of thing going on in the selection process, where they were observing you to see, how well you would be able to perform with your teammates and your crewmates and so forth.
In any of those tests, were your skills as an engineer or a pilot an advantage in any of those physical or psychological tests?
Oh, I think so. Yeah, just understanding what's going on, and I would ask them questions. Well, why are you doing this, or tell me about your test. What are you trying to learn? So it was educational. And they were glad to tell you what they were doing too. They all had their little research program going on one aspect of human physiology or psychology or whatever, and they were glad to tell you why they were doing that test. So I found it fascinating. One of the more memorable was they wanted you to climb inside of what looked like a large beach ball, a big white ball with a cord coming out of it that would provide air, and you would climb inside this, and they would zip it up. And the story that went with it is that we launch a shuttle into space, and then the shuttle becomes stranded. We want to launch another shuttle up into space and transfer the people from one to the other, and we don't have enough spacesuits, so we want to put you in this ball and make sure you're comfortable in there, and then they'll move you from one space shuttle to the next. Well, that was just a cover story. They were really trying to see if you're claustrophobic.
Oh.
What they would do is they would put an EKG on you first, so they could watch your heart rate, and then they put you inside this ball and zip it up. It was totally black; you couldn't see anything, and you'd be in there for 10 or 15 minutes. They'd observe you to see if you were getting a rapid heart rate or something because you felt nervous or claustrophobic or whatever. So that was interesting. I climbed in and took a little nap. I think my pulse went down to 40 or something.
And so the physical tests that you had to take weren't so much about physical strength so much as your mental sort of endurance through that particular event.
Yes, I think the physical testing wasn't so much strength as it was mobility and dexterity.
Okay. And so you do have a story that you tell about you took a bunch of tests and you actually failed one, and then you did this 1-hour interview. So can you tell that story?
Yeah, actually, it played to my advantage. I think my interview was on Wednesday, as I recall. So after 2 days of testing, well, the first day they did a lot of blood work, of course. The second day, the results came back that I had a very high level of uric acid in my blood. So my first question was, what's uric acid? I said, well, it's caused by eating too many avocados or something like that. I don't know. And I said, well, I don't eat avocados. He said, well, you've got high uric acid. So they took the blood test again, and it came back later that afternoon, still high. So the doctors are kind of telling me I'm out of the limits. So I'm figuring, oh, it was nice. This is fun. I got to meet 19 other people, several of whom will probably become astronauts. And it was a great experience. I'm glad I did this, but I didn't make it. It was so when I went into the interview on Wednesday, I was actually kind of more laid back than I would have been otherwise, I think, which probably helped me a little bit get through that nail biting hour, with all these people that walked on the moon and all.
Can you remember and can you share an example of a question that they asked you in that interview?
They would ask you about your career, and again, I think they were always probing how does this person get along with other people, and technical work. It asked you to explain, something technical to see if you could articulate what it is you were doing. And then they asked a lot of questions about Bell Laboratories, and I was so fortunate to be in this position because I barely knew that several of my bosses at Bell Laboratories had worked, for NASA during the Apollo program. NASA had taken 200 engineers from Bell Laboratories, mostly in New Jersey, and moved them down to Washington and created an organization called Bellcom, which was there to serve Apollo. So these astronauts and the managers at NASA that had interfaced and worked with them, they picked the lunar landing sites and did the trajectory analysis back and forth to the moon, all those kind of technical things. They loved Bell Laboratories. That was the best thing the government did, was to bring those couple hundred people into the organization there. So I got a free ride at that, plus the National Guard. The fact that I was flying fighters on the weekends and working with these amazing people at Bell Laboratories put me in a good position. I was totally unaware that was going to happen.
Well, so where were you when you got the call that you had made the cut to be an astronaut?
Well, they were supposed to make the decision at the end of 77 in December, but the holidays came and went, and they still hadn't made a decision. And they were saying there would be 40, but now all of a sudden it was going to be 35, so they reduced the number down to 35. On my way into work that morning, it comes on the radio that today's the day they're going to make the announcement. So my colleagues who are in the carpool there were saying, okay, we've got our fingers crossed. I said, nah, it's not going to happen. I got this blood problem. They're not going to pick me. And NASA released of the 35, there'd be 6 women, the first 6 women astronauts. And I said, well, now I got no chance at all now. All right, we're down to 29 right now. And so I got to work, and about an hour later, George Abbey, the head of flight operation, calls me, and he's kind of a low-key guy, talks very softly and all. And he said, well, Terry, he said, if you like, we got a job here. And I heard him say that. I said, well, was he offering me a job as an engineer or an astronaut or what? He said, no. He said, well, we want you to be an astronaut. I said, okay, I'll take it.
Now, you were part of Astronaut Group 8, and that was the first new group of astronauts I read in 9 years. So if that's wrong, correct me.
Sounds about right.
Okay. And the first to include African and Asian Americans as well as women. And one of those women was Sally Ride, and she was the first American woman in space. And, you've said that you were best friends, you and she, and that you shared an office and you flew T-38s together, and that she was one of your favorite co-pilots. And I was just wondering if you could share a story about her that you think really reveals her character.
Yeah, she was a wonderful person. All six of those women had to do extra at NASA because of the extra public affairs burden that they had to carry, and they all carried it with grace. Yeah, Sally, we actually met. We were in the same group of 20 that were tested together, so we actually got to know each other. And when I met her, I said, "Well, here's a young woman that's played as a professional tennis player. Has got a PhD in astrophysics." I said to myself, "They're going to pick her," and of course they did. So we ended up sharing an office together. Then she and I and Steve Neckel. So the three of us would fly together a lot in the T-38s. She being a professional athlete, she was particularly gifted in her dexterity or hand-eye coordination and so forth. And flying the T-38 from the back is a little more difficult than the front. I mean, all the controls are there. That's where the instructor pilot sits in the Air Force. Yeah, but she picked up on it right away, and not just with me, but with other astronauts in the front seat. They let her land the airplane from the back, being careful and safe and everything. But she learned how to land the airplane pretty quickly, and that was not part of the program. That wasn't supposed to be done. And I remember one time we were on our way up to Buckley Air Base up in Colorado from Houston, and we were on Steve's wing, and she was in my back seat, and we're climbing up. And I said, Sally, have you ever done a canopy roll? So a canopy roll is when you're on the wing of the airplane, and then you go up and over it, and then roll all the way around, upside down and back down on the other wing. You kind of make a little half circle over top of the other airplane, but back a little bit so it's not unsafe. So she said, "No, what's that?" So I showed her one, and I did, okay. And she said, "Yeah, let me try that." So she did the first one, and it was, okay. It wasn't quite as good as mine. By the time she'd done the third or fourth one, she was doing it better than I was. So when she came to Lehigh, it must have been 10 years ago, and I introduced her with that story. When I started the story, she looked at me and said, "I know exactly what you're talking about." So, one of those moments in training that's so memorable.
Oh, that's great. That's really great. And okay, so early on in your astronaut training, you were called on specifically because of your mechanical engineering background. And can you tell us the story behind that?
Yeah, early in the space shuttle program, so this was 78, and we showed up in the summer of 78. And they thought at the time the space shuttle was going to make its first flight in 79. So we thought we were like 1 year away from launch. But the tiles were falling off the shuttle, and the engines were blowing up. There was lots of development problems, so we ended up not flying the first flight until like 3 years after we showed up. But there was lots of work to do. So one morning, the story I've always remembered. I'm walking down the hall in the astronaut office, and here coming the other way is John Young, the chief of the astronaut, a commander of Apollo 16. Walked on the moon, went to the moon twice, walked on the moon once. So John starts talking to me about 10 feet out. He said, "TJ," they always call me TJ. He says, you have an engineering background, right?" And about this time, he's going by me, but he doesn't stop. He just keeps walking. So I do a little U-turn, and I said, "Yeah, I went to Lehigh, and I'm mechanical engineering. I had some courses in aerospace and so forth." He said, "Well, I got a job for you." But this time we turn into the bathroom. So he goes into the men's room. So I follow him into the men's room. Of course, you know where he's going. So he closes the door, and he continues talking to me there. So I'm there, and he's chatting away. He said, "Well, these engines have been blowing up a lot, lately. And it looks like they're doing better. But I really need someone down there at Huntsville, Alabama, talking to the NASA engineers that can come back here and give me the real story about what's going on. So can you do that?" And I said, "Well, yeah, I'd love to do that, John." I said, "Okay." And then by this time we're coming out of the bathroom, now we're walking back down the hall. And he said, but really, TJ, I want you to keep those engines from killing me, okay?" He was going to command the first mission. And he said, just don't let those engines blow us up, okay?" And so I went about my duty. It was about the most distinct assignment I've ever had. And every Monday morning, then I would report back to the office in the Monday morning meeting. I would give a short readout on whatever testing results had happened that week. And I spent a lot of time in Bay St. Louis, where they tested the engines, and up in Huntsville, where they did the design work. So it was, for a mechanical engineer, it was like being in a candy store, having all this technology to work with and to watch these engineers figure out how to make this engine work. And then those engines were all through the shuttle program. They were close to being perfect. We never had a failure due to the shuttle's main engines.
Wow. So is there like a moral of sorts that you pull out of that story for your students? Because that was early. I mean, you had just gotten to NASA and you're given this pretty distinct mandate of don't kill the top guy here. And I think I read somewhere that it was a little intimidating having to give these readouts at first. So,
Yep,
sure. What did you take out of that experience that maybe you give to your students now?
Well, I remember probably a month into this assignment, there was a major explosion on the launch pad, or on the test pad in St. Louis. And I had the next morning, or it was 2 mornings later, I had to explain that then to the astronaut office what went wrong. The whole test stand got blown away. It was really pretty terrible. Of course, we didn't know exactly what happened at that point. It took another week or two to figure it out. But that was pretty intimidating experience to stand up for all these people that wanted to fly on this machine and explain to them this terrible explosion had happened and all. But you learn and you move forward. You're going to have setbacks. Of course, we had two major setbacks in the shuttle program. We lost two vehicles for other different kinds of reasons. But you pick yourself up and dust yourself off and figure out what's wrong and try to keep moving forward.
Yeah, yeah. And then was it about a year into your training that you were asked to become a Capcom? Is that right?
Yeah, that was my next assignment. And that's really the best assignment you can have as a trainee, as an astronaut trainee. The Capcom is short for Capsule Communicator. It kind of goes back to the Mercury program, where in any time in mission control that there'd be a mission ongoing, they would always have an astronaut in mission control on the radio. So the flight director would tell the astronaut what to tell the crew to do. So they figured that was always best from a communication point of view, to have that astronaut to astronaut kind of link. So we were trained through all the simulations in mission control with the crew in the simulator in a different building. And we train hour after hour going through different scenarios to recover from failures and so forth in simulated missions.
Like, what are they simulating? What's an example of?
Well, I was on the launch team, the so-called ascent team. So there were three different teams. So you'd work 8-hour shifts around the clock then. So the ascent team, of course, would be there for the launch itself. And then for several hours afterwards, they'd hand over to the next team. So we would ordinarily do simulations on the launch where they would fail an engine or cause some other kind of problem. And then the mission control team and the crew together would have to figure out how to do the right thing, hopefully to keep the mission going, but if not, how to abort and get back safely. So all those kind of scenarios we'd rehearse hour after hour, day after day. And then occasionally you would do what we call long duration simulations, where you'd simulate a whole 3-day period of a mission. Since this was STS-1, the whole mission was only 3 days, so we would simulate the entire mission from liftoff right through landing, and get a lot of good experience and training.
So your role is the Capcom is to communicate to the astronauts what mission control wants them to do?
Right.
And are you simultaneously at other points in the day doing those same simulations yourself? Or did you not do it until it was time for your flight?
Not till you're within usually 6 months of your launch do you get enough priority to get in the simulator. Prior to that, during a mission, though, there'd be some, if you saw Apollo 13, for example, during a mission, if something went wrong, they would send, the Capcom would still be in mission control, but they would send another crew to a simulator to put the simulator in the configuration of the spacecraft that's in trouble, so that you can try to come up with what you're going to do to work around the problem, test it in the simulator. Then the Capcom would send that solution up to the crew to try in space.
Okay. So initially in your role as a Capcom, you're giving directions about something that you actually yourself haven't even done yet.
That's true, yeah. But of course, you learn by watching them do it in the simulator. All the data from the simulator, plus some that the crew can't see, you can see at your console. That's really the tip of a very large pyramid. And inside the mission control room, there's probably 20 engineers. There's a flight director, 16 or 17 engineers, and usually 2 Capcoms on as backups during that. But that's just in that room. In the rooms surrounding that in the same building, there's probably another 200 engineers that are specialists on their particular systems, hydraulics or the engines or environmental systems and so forth. And then beyond that, there's even people out in industry all around the country. The engineers at the companies that made that hardware have even more detailed understanding of how it works than the NASA engineers. So anytime something goes wrong, that whole pyramid goes into high gear to analyze the problem and figure out, how to fix it.
There is a story from your Capcom experience of that first mission that revolved around the tiles. Do you mind telling that story? Because that is kind of, you described it as nail biting, and I think that's a good description.
Yeah, it was. So I was at Capcom in mission control. So we launched, and those of us in the room were probably the only people in America that didn't see the liftoff, because we're not allowed to have cameras. We got to watch our data, So the crew goes up, and the launch, of course, was successful, and the space shuttle's in orbit. And then the crew opened up the doors, and when they opened up the doors and looked back by the tail, you can look out the aft pointing windows. By the shuttle tail, some of the tiles, the white tiles, were missing. And you could see the black coating underneath was visible. So we said, "Uh-oh," and those are problem, maybe not on top because there's not a whole lot of heating on top, but we figured because there's been all this history of tiles coming off during the manufacturing process, and we were worried maybe some tiles came off the bottom as well. So we handed over then to the on-orbit team, and our mission control team went off duty then for 2 shifts. And then we came back on duty right after they put the crew to sleep on the first night. So we were just there watching the spacecraft. There's nothing for the Capcom to do. And Gene Kranz, the famous flight director who was played by Ed Harris in the movie Apollo 13, amazing guy. But Gene Kranz came up to me and he said, "TJ, we got to wake the crew up." And I said, "Well, why do you want to wake the crew up, Gene? I just went to bed." We knew they weren't to sleep yet. But he said, "We got to tell them to point the space shuttle to this other attitude, a strange attitude. Usually we're flying around upside down so you can see the Earth." And I said, "Well, why are we doing that, Gene?" He said, "Well, I can't tell you." I said, "Gene, come on." I said, "Don't worry, the crew will figure it out." So I wake them up, and then they weren't too upset. They do the maneuver, and then he said, "Okay, put them back to sleep then." And they put them back to sleep. And again, we went off shift, and I'm thinking, what is all this about, And then we came back in again for the next shift the next day, and we have to be on duty again. And Gene came up to me and said, "TJ, tell the crew that everything's fine with the tiles on the bottom of the shuttle." And I said, "Gene, what are you talking about? How do we know that?" He said, "Well, I can't show you." So I got kind of upset with him. I said, "Gene, come on." And so he opens up this folder, and here's a picture of the bottom of the space shuttle. And you can see every tile was right where it had to be. They turned the space shuttle to the right attitude so the sun could shine on the bottom. And this other satellite that we have, it took a picture of the bottom of the shuttle. And of course, that's all. This didn't become declassified until a few years ago that we have such things. But back in this is 1981, that was highly classified that we had it. So, but NASA had called the Air Force and said, "Can you help us here figure out whether the shuttle's okay?" And they came back with the answer that it was fine.
And so can you just explain what is the significance of those tiles and why was that such a concern that they might be missing?
Yeah, when the shuttle or any vehicle re-enters the atmosphere, it's doing 25 times the speed of sound. It's doing like 18,000 miles an hour. And at those extreme temperatures, the velocities, the temperatures get very high, about 3,000 degrees Fahrenheit on the heat shield. So the space shuttle was only made out of aluminum. Aluminum starts to melt at around 800 or 900 degrees Fahrenheit. So it can't withstand that heat. So the tiles were usually, depend on where they were, but they're anywhere from 1 inch to about 4 inches thick of silica. And it was extremely heat resistant, so it would protect the shuttle. But if one of those were missing, then the heat would immediately melt the aluminum underneath, and you'd have a loss of the vehicle.
So even if just one is missing, that could. Oh wow.
Yeah, well, they predicted if one was missing, there'd be a zipper effect that the aerodynamic forces would cause the pressure to build up in that cavity, which would cause the ones surrounding that to also come off. So you'd end up with a big hole.
That's it for part 1 of my interview with Lehigh alum, professor of practice, former telecom executive, inventor, fighter pilot, and astronaut, Terry Hart. In our next episode, Terry takes us into space and through the maneuver that made history. He describes how he turned down another trip into orbit and why he calls being named to deliver the commencement address the honor of his life. For more information about academic programs at the P.C. Rawson College of Engineering and Applied Science, and to find our show, head to engineering.lehigh.edu. Music in this episode is by Blue Dot Sessions. You can subscribe to Rawson Connection wherever you prefer to listen. And send us story suggestions or feedback on Twitter @Rawson Podcast. Thanks for listening, and stay safe.